Okay, so in this segment, I'm going to go ahead and carry out those steps. First, I'm going to take my question and minimize it, give myself a little more space. These three steps, I think I'll minimize those also. You can refer back to them. And I'll take my entire free body diagram and minimize that a little bit. Oops. Give myself a little more room to work. So the first thing I said I was going to do is find the components. So I'm going to do that. I'm going to redraw this so it's a little bit bigger. There's my y-axis, there's my x-axis, and here is my weight vector right here. Now the components of that are the portion of that along the x-axis up to a line perpendicular to the x-axis. And the same thing is true with the y-axis. Okay, there's a perpendicular down to the y-axis. All right, so let's see. If this is theta, which is 34 degrees, then this up here must be 90 minus theta. You can see the right triangle there. Remember, the weight vector always acts straight down, so that's also a right angle. So if that's 34, then that's not 34, but that is 34. So that's also 34 degrees. Okay, so how does that help me? Well, we can say that the sine of 34 degrees should equal the opposite side, which will be this side here, which is the same length as that side there, and that is the x component of the weight, divided by the hypotenuse, which is the weight. And therefore, the x component of the weight will be equal to WEC sine 34 degrees. Similarly, I can find the y component by saying that cosine 34 degrees should be equal to WECY, that's over here. Here's WECX, and also down there. And that'll be over WEC, the hypotenuse. Okay? So then, again, WECY will be equal to WEC cosine 34 degrees. And there we have at least an algebraic expression for both the x and y components. Now I'm going to take that work and minimize it, leave us with a little more space to work. We'll bring that up there because we might want to access that later. Okay. And then I'm going to go over and grab my x-axis equation and move that over here so I can work there. And now we're going to be able to do some substitutions here. So let's take what we are, a couple of substitutions to start off with. So let's drop this part, give ourselves a little more space. So we'll work from here. Now, I know that friction force is mu times the normal force. We found that out in our lab work. So I'm going to do a substitution. Wherever I see friction force, I'm going to put in normal force times mu. So minus mu times, and the normal force, ramp on cart, minus, and this is going to be WEC times sine 34 degrees. That'll equal MAX. Notice one of the things I'm doing is some algebraic substitution. We'll pick up the rest of the solution in the third video.